How's it going, folks? It's Frisky. Got a video for you this time. Well, as usual, it's a little bit different from what I normally do. I kind of just go everywhere. As far as the anti-chamber playthrough goes, I had some problems with recording, and I ended up losing some of the files that I had recorded, and I had decided that I'm just going to scrap it. I would rather not go through and play all over again. It was kind of a one-time thing. Game is amazing. Haven't finished it the full way through yet, still in progress, but just lost too much of it to go back. Anyways, this here is my Raspberry Pi. If you can see here, it's in a little enclosure. I've got a SD card there, it's 16 gigs. It's actually a micro SD. I got a little Wi-Fi adapter here so I can remote SSH connection into here to edit all the files. Normally I have this little breadboard here hooked up to the Pi on the header here with this the breakout cable, but in this case I do not, because I don't need it for this demonstration. Anyways, this is the 16:2 LCD display and backpack from Adafruit, or Adafruit rather, and it's like 25 bucks. This is the RGB display, so it supports let's see, whatever combination. So there's red, green, and blue. There's, I guess it's just 6: red, green, blue, violet, which is technically magenta, cyan, and yellow, and then there's white and off. So there's the 6 colors. You have the white, and then you have an off state, which is like this. This is the default boot up state, these blocks up there, just because I haven't run anything on it yet, even though it's receiving power. So let me just show you what I was doing here. I got a couple things that I want to show you. First being the most simple, which is the system monitor. So all of the code for all of this stuff is going to be available in the description. Pastebin links in the order that I show them. Disclaimer here, I am not a Python pro. I took a Python class a couple of years ago and I stopped using it. I am a computer science major, so I know C++, but I don't know a whole lot of Python. This is basically my entire experience with Python. It's very easy to get used to, but there are a lot of nuances between something like I'm used to, like C++, and this. There's just a lot of difference. Even though they're both technically object-oriented, Python is just a little bit different in that regard. It's a little bit more of a scripting language. There's a fine line, but anyways, my code is not probably the best way to do any of it. It is the way that works, and for what it does, if you just need it to work, then my code is great. I have not found any withstanding bugs with this, or any of these, unless I do mention them. So with that, we'll get started. So the first one, the system monitor. I believe the green color shows up best on these on actual video cameras. So the fact that I'm recording this on my desk here, I'm gonna put it all in green for the most part, just so it's easy to see. So I'm gonna just hit run here. It opens up an SSH prompt, and then hopefully you can see that it is a little bit bright. Give the camera a second to adjust the contrast there. Yeah, so you can see that right now it's got it's just a simple memory display. It shows you how many kilobytes of memory you have out of a certain amount. So depending on what how much memory you've allocated for your GPU on your Raspberry Pi, which can be done with the command raspi-config. Run that as sudo, and then you can change the amount of memory that's allocated to your GPU, and then whatever's left of your 256, or in the newer models of the Raspberry Pis, the 512, will be usable by the OS. I have the older model, the Model B, 256 megabyte. So you see the total is 237,648 kilobytes. So that says that I probably have 16 megabytes of GPU memory dedicated in that configuration. So that's just that first bit. There's nothing really too complicated about that. I can show you that it updates in real time, although you might have seen it already. I'm going to open up a PuTTY terminal, and I'll just, if you notice, it's probably dropping already. Like if I type in pi, hit enter, it's going to drop a little bit more. Now I type in password. It's going to drop a little bit more. Yeah, see, no, it updates in real time, so it's really cool to see how it sits there and it's allocating memory and it's rapidly dropping, and it updates very, very frequently. The way my code works is it only refreshes the display if the value has changed, and in this case the value it doesn't change very rapidly. Like when it's at idle, I was surprised by this. I don't know a whole lot about the internal workings of Linux, but it does not change very rapidly until you do something. So right now I'm not doing anything, but the value is not changing, so the display does not refresh until it's realized that the value has changed. Which works because if you sit there and refresh a display, you get a lot of flickering in the LCD. You notice that when it rapidly changes, it flickers a little bit. I don't know if you can see that on the video camera here, but it does. So that's just an explanation of that. If I just go exit. I apologize for the loud keyboard. I have a desk mic and it's a mechanical keyboard. Amazing keyboard, but it is a little bit loud. Anyways, if I just go back here, I can show you which of these actually work here. This one is not what I want. I want menu concept. Okay, so this is my venture into a little bit more of a complicated complicated Python. As far as complicated goes, for me anyways, it's probably not complicated in the least, but for me this was a venture into classes. I'm used to classes in C++, and they're rather different in Python, but nevertheless I was able to get it going. Essentially this is a interface. It's not a class. I had some trouble getting it as an extensible class because you have to be able to set the menu items, but it's a class making a list of things that can be displayed and scrolled through despite the fact that there's only 2 rows on the display. So I have right here just at the bottom, you can, there's a little command set entry. You can set the number of the entry and then whatever text you want to show there. I can just leave those as just kind of a generic, just whatever I felt like putting in there. But if I go ahead and I run it, menu.py, I gotta save it. Let me exit, run. Okay, so as you can see here, it's got play game and options. Let me see if I can change the color here. Okay, that does look a little bit better. This is the white color, so it's just every red, green, and blue are all activated right now, so you get the white. But I don't know, it's a little bit dark down here because of the contrast from the screen, but you've got the 5 little push buttons here. The one on the far left right there is the select button, and then this is right, up, down, and left. So you can actually scroll through, like I'm pushing up and down right now. The little character there, the is greater than sign, scrolls through these things. So it's basically just a list of things, and whenever you press select, whatever's highlighted can execute code. So right now nothing other than the quit will execute anything, but this is just a proof of concept, so it scrolls only when you try and scroll off of the screen. So right now it doesn't have to scroll at all. It can go to the bottom and to the top, but as soon as you push up, it's not going to do anything. It goes to the top of the list. And if you push down, if you try and go off of the screen, it's going to increment 1 down, and the cursor won't change position. It's something you kind of take for granted when you use menus in general, but it's actually somewhat complicated because you have to keep track of where the cursor is and all that kind of thing. But if we go to the bottom here, again, the bottom is also limited, so you can't scroll off the bottom. And we hit select, it can execute code. So that was just quitting. Basically, that just ends the script. So that was that. The code can be picked up. Again, in the description, you'll see that right down here, the function here, pick entry. You just basically have a bunch of if and else statements, and those numbers correspond to the entry in that menu. It's pretty simple. So yeah, you can see the last one here. The 5th item was quitting, or was the quit down here, set entry 5, quit. So the 5th entry is going to be the num here, and it's just going to print quitting in the console, and then display everything, and then clear the LCD and turn it off. And then that will end the script because it sets this displaying value to false. Okay, so what I wanted to show you next was something that I had been working on, and I'm very, very proud of. Something that it's complicated, but it's not hard to do. I'm just I don't know. It's bewildering to see that something like the Raspberry Pi can do this. But so if you're familiar with the way that radio waves work, the standard radios have FM bands and AM bands. AM bands are, if I recall, much shorter than FM bands, which would make sense seeing as AM bands travel much less distance. FM bands go farther, but I don't really know what I was saying. Anyways, the way that the Pi is set up is there's some internal clocking mechanisms that some people at like a hackerspace, I believe it was, they came up with some code that took advantage of this clocking mechanism and one of the GPIO pins, and they're able to simulate an FM transmitter. So it gets very complicated, but the way that FM transmission works is you have like clock speeds, and you have to like it's like widths of wavelengths have to be like modulated. It's weird. I don't even remotely begin to understand it. It's called Pi FM, and basically RM Hole, I believe, is the one that started it. Okay, yes. So essentially, what this does is it's some software written in C that allows you to use Python to play 16-bit mono wave files, so lossless, maybe not lossless, but at least wave format sound files over a FM signal, assuming that you have some sort of antenna. And the antenna, all it really has to be is like a 20-centimeter long wire coming out of the proper GPIO pin. So what I did here in this case is I just attached my GPIO breakout header thing. If I can actually successfully do that, that'd be great. Okay, so that looks like that's on there nice and okay. So what that does is just basically taking that pin and then just extending it, and that's all I really need. Is I just need that that extra length to act as the antenna. I don't remember which GPIO it was. It's on here, GPIO 4. So that is what is going to be broadcasted on. So I wrote a little Python script to automate this. The way it works is it uses a little menu, and not the menu that I had developed earlier, but a more simple, just two option menu. So if I start the script here, you'll see on the display here, there are two options: one for the changing the frequency, and another for changing the sound. So all of this is written by me. Basically, what the Pi FM library gives me is a way to supply it with a frequency and a sound file, and those sound files will play until they are done, and then the script will exit. I've modified everything a little bit with Python, so you can interrupt it, you can change the frequency on the fly without having to wait and all that kind of thing, without having to go do that all from the command line. So if I go ahead and go to my change sound menu, you can scroll up and down through the list of items in a certain folder. So the subfolder is just sounds, is a folder that's in the same folder as the script, and all the wave files that are in there show up in this list. So right now I have the Star Wars theme, and then I have PDA by Interpol on there, and I'm gonna play Star Wars, hoping to avoid any sort of copyright infringement here. But we're going to change it to Star Wars. We'll just hit select here, and we're going to go up to the frequency. So it starts with 97.1 here where I am in California. I found this to be the quietest frequency without a whole lot of interruption. The way it works is that stations that broadcast on frequencies that are popular, like over here 1017, which is actually a terrible top 40 now, and 1049 and things like that, they're very busy because the broadcast stations for those stations need to be extremely powerful because they're popular stations. And because of this, what happens is rather than taking over the frequency within the about 300-foot range, 100 meters or so, from the Pi, it kind of like meshes together with it. It's not enough to fully take it over because the signal from the actual broadcast station is too strong. So if you find something quiet like 97.1, it works great. So what I'm going to do is go ahead and find my radio. Okay, so I've got my radio here. I'm going to avoid moving the camera because for various reasons. So I'm going to take this and plug it in. Okay, so right now it's 12 o'clock. Not at all. But you see this little dial down there. We're going to dial it to, actually it looks like it's already where 97.1 should be. So if I move that off to the side, we'll bring the Pi back over here. The way this little menu works is you can push up and down to increment and decrement the frequency by 1. So you can go up and down like that. Come on, focus. And then the left and right increment by 0.1 megahertz. So if we pick 97.1 and we hit go, screen turns green, and we'll turn the radio on. Boom. And if we change the frequency, let me turn the volume down. If we change the frequency, we just go back into that menu and let's increment it to 97.9. FM band frequencies, they like odd multiples of 1. So 0.1, 0.3, 0.5, 0.7, and 0.9 are better than their even counterparts. So if we change it to 97.9, we'll go ahead over here and we'll tune it. There you go. So you'll notice that it's a little bit staticky, and that's because it's interfering with stations around it, which is why 97.1 works great. So I can again, I can go and change the sound. Let's see, I'll try PDA. If we go to frequency, we'll go back to 97.1 and boom. So that is how that works. Once that song is over, it actually turns back to the white color, so you know that it's broadcasting without actually hearing the broadcast because the screen is green. Anyways, those are my Pi projects that I've been doing right now. Just got all those parts in, and it really, breathes some new life into the Pi itself. So thank you guys for watching. If you have any questions about what I did, please don't hesitate to ask in the comments if you have any questions about my code, anything like that, which again will all be in the description. Please don't hesitate to ask. I'm more than willing to answer. So anyways, guys, you probably should expect some new Pi videos in the future, bringing you guys some cool new stuff. So give us a subscribe, give me a thumbs up, whatever, if you feel like it. If not, that's okay too. See you guys later.